Everyone, welcome. This is the SIG Node meeting on January 6th, 2026. First up, we have Sergey.
Happy New Year, everybody. Welcome to the first meeting. I wanted to bring this email from Teams. Traditionally, we look at, in the beginning of every release, we look at features that stuck in uh, various stages. We have few alpha and few beta features stuck. You can see the full list of feature gates that stuck from Teams email on a link. Some of them related to SIG Node. And this release, I mean, traditionally we take few of them and try to move through the GA. If you interested in moving any of them to GA, we definitely will support you. So please take a look and for upcoming enhancement discussions, if you want to participate in that, please let us know and we will help you out.
Yeah, thank you for that announcement. Okay, there's nothing else there. I guess Chris is here.
Hi, yeah, Happy New Year. I actually don't really have any updates. I haven't had a chance to circle back to this, so maybe we can defer this to a future meeting.
Totally, that sounds good. All right, Philip.
Hey, can I share my screen?
Yeah, just a sec. There you go.
Okay, so I would like to go over the eviction request cap a bit, since we made some some changes since I've shown this last time. So basically, we decided to simplify the cap, so we can move forward with this. And yeah, I will quickly go through the changes and also discuss some implications we have with SIG scheduling. Yeah, so to reiterate for people who are not familiar with this cap, this is like an improvement for how to do pod eviction or pod termination, and compared to the eviction API, which is present in Kubernetes today, this allows us to do eviction declaratively. So we can define a set of interceptors on a pod, and before the pod and like we will have a new disruption method for evicting the pods by creating the eviction request. And this is like a synchronous way of terminating a pod, and it allows us to define like special behaviors that should happen before the pod is evicted, and this is defined by a set of interceptors. And these interceptors have a way to block the pod termination until they like exit or terminate the pod. And this can, for example, implement pod migration or faster application scale up. So basically allow us to implement much more nuanced and graceful and safer behaviors. And so, like to start simple and not overburden the API, we decided to make the interceptor simple. And right now, we just have a name for the interceptor. So before it was called class, now it's called just a name. We removed the priority and the role. And so now the ordering is done only by the list index on the pod. The other major change was that we do not allow like mutability of these interceptors, so only the controller creating the pod has a way of defining the interceptor. And also we don't allow changing the interceptors like during the eviction request creation time. So these interceptors would be copied from the pod to the eviction request spec. And this allows all the consumers of the pods or of the eviction requests to know what kind of interceptors will run even before the eviction request is initiated. The immutability part may be limiting, since we want like this to be used by like many actors that would like to interact with the pod lifecycle. For example, with regards like the scheduling or some like additional behaviors as the pod migration or like higher level controllers. Yeah, so these are the major changes in the API, and we will come back to this later in Alpha 2 or Beta, and decide like if we want to introduce some like kind of better ordering, not just index-based ordering of the interceptors, or if we want to change the mutability for on the pods. Okay, so yeah, now I will talk about the scheduling perspective. Yes, so like I added these two sections for here workload API support and preemption support. So to make sure that we do not like go in or the other direct direction, or do not like implement something that the workload API would struggle with. Like we decided to opt out of the workload API support in alpha at least, and we have a plan to actually to support the workload API in the future. So in the eviction request spec, we have an option of a target, and now the target is only a pod. So the API is a generic, like the interceptor interactions and the requesters, it can work for other types than pods. So we reserve like to have other targets, and we would like to add a workload reference here. So we could basically like evict a workload as a whole, and not just a pod. And like the SIG scheduling is working on an enhancement that's adding a preemption support, and they are defining a similar thing. So I now here I have the preemption cap they are working on, and they are defining how to do a preemption. Like if you can do like a single preemption of a pod, or if you need to preempt the whole pod group, and we like would like to reuse this, or yeah, so like we would like to basically have a similar way to evict a pod as a pod or a pod group. Yeah, I see a question from John.
Yeah, so I just wanted to, you had mentioned workload, and I just wanted to bring up pod group. And one of the discussions happening right now is whether pod group will become its own top level resource. So I wanted to make sure you synced up on that discussion and put in your 2 cents. That's all.
Yeah, thanks. Yeah, I didn't know that. Then it should be a new resource.
I can give you the document here. 1 second. I'll add the document to the agenda here.
Okay, cool. Thanks.
Yep.
Yeah. So yeah, this is like we just like know like what kind of like evolution the eviction API would like to go through. So since we like disable the workload API support in alpha, like we can change this like to add the preemption or like disruption modes like in the future, depending like on what SIG scheduling decides on. So like we could for example have the pod group disruption. So in that way we would not allow disruption of a single pod if it is a part of a pod group, and basically would fail on admission, and only allow the pod group, which would basically just go through the set of pods and evict them all at the same time. Yeah, I see that Don has her mic up. Do you want to add something?
The only thing I just yes, just thanks for John's comment. At KubeCon last year, actually, I believe Philip and you and we talked to the Eric Tong, especially on those workload API and the pod group. But we are not in details for sure because it's a short time. We did discuss those kind of things. And another thing it is, I did send this cap explicitly sent to the both Eric Tong and Clayton for the detail of the review. And of course the team hacking. So that's why we have like the KubeCon couple hour follow up with team hacking. So that's kind of what we're doing. But I haven't received the detail of the feedback from Clayton yet. We did receive some detail of the really detail of the feedback from team hacking, some level of the feedback from Eric Tong, but I'm not sure Eric communicate with you folks his feedback yet.
Yeah, so yeah, we've had some conversations with Eric about that, and yeah, I think like we decided to not support workload API at this time. So I think like we are not blocked if we want this cap to be targeted for 136. So like we will basically just fail on admission, like when people want to create eviction requests for pods that have a workload reference. That's all we will do, and you will see how the SIG scheduling progresses, and then we can add like a proper support for these pods. Okay, and the same thing or similar thing is with the preemption support. So now we are seeing changes done to the preemption workflow, and like we have a couple of choices how to implement preemption like with the eviction request support, which it's not an easy topic since like the eviction requests with interceptors can basically go against preemption since they can delay the termination of a pod for a long time. So it would be useful at least to add like expected interceptor finish time to pods, so the preemption API knows like what kind of pods will like struggle with terminating, and then we can also like suggest other preemption policies. But this is also like a advanced topic, and this is just like a outline of what we could do. But we will explore this also like after alpha. So like we strive to like make like the proof of or like the minimum viable product in alpha, and like disable all the like bells and whistles, and once we are sure like what we want to do, like we can enable them one by one. Yeah, Kevin.
Yeah, I was gonna say that there's also another cap around like workload API and preemption. So this is another one that might be interesting to try and do right now. GitHub seems to be crashing, but yeah, I can link it here. But at least I know that they're like I just wanted to call that out.
Okay, thanks. Yeah, please. Yeah, so add the link later. Thanks. Okay, I think yeah, this is mostly it. Or Kevin, do you want to say something?
Sorry, that was my hand up from previous time.
Okay, that's fine. Okay, so these are like the major changes. So, like yeah, we simplified the API, added like the consequences for scheduling, And I removed also like a bunch of advanced use cases we have had here, like what for the follow-ups, since it was cluttering the gap. So it is much more concise, and we we will try to like add on these features later in Alpha 2 or in Beta, and and decide what's the best for the API. So like I would appreciate like any reviews or suggestions to this gap, and I would like to target this for 136. Yeah.
Have you? I saw that. I just haven't really looked at this in a while, but I saw like what we were calling like batch jobs out of scope. Has there been any consideration looking at like leader worker set in this like workload API and how like it could possibly work? Because like it seems like I could imagine this being useful for serving.
Okay, so like the out of scope is mainly the discussion about like the core Kubernetes workloads, about the jobs and cron jobs API, like which we do not want to get into yet. And these are only suggestions, like what we might do, but this is it's not that important. Like to have these. Like the main case is like to enable like various set of use cases. And like other projects, like leader worker sets could like implement their own interceptors and experiment like what they want to achieve. So nothing is blocking that.
Okay.
Yeah, and also one of the use cases. So we've had a discussion with the checkpoint restore working group, and they are also interested in this. So we added a user story for the checkpoint restore logic, and we are also have one doc where we will try to outline like the integration with like eviction request and checkpoint restore. Okay, unless there are questions, that's all. Thanks.
Thank you, Philip. Yeah, looking forward to iterating more on the cap. I like the eviction request design a lot more now. It feels a lot more straightforward, so I'm excited to see it continuing to make progress. Okay, that's that. Sergey, you had one?
Yeah, just service announcement. We used to have Google Groups group on public Google Groups domain, and now we moved to Kates.io. We moved a long time ago, but old emails were still used from time to time. So I disabled the ability to send emails to the old Google Groups. So if you want to make an announcement, send it to new Google Group.
Yeah, totally. And I committed this problem right before the new year, so I have to remember this myself. Great, thank you. John, you're up.
Yeah, so one of there's an enhancement issue I created, and we're looking at hopefully doing an alpha on this cap, and I wanted to know, I think it's probably SIG Node that should own it. It's because it's kind of a core DRA thing. So basically, if you think about right now, when a resource claim pulls in for or allocates something out of a resource slice, the only place that state is stored is in the resource claim. And so if you're a user and you want to know, hey, how many GPUs on this node are consumed, it's actually really hard to find that out because those resource claims may be scattered across many namespaces, some of which you don't even have access to, right? And so what we want to do is introduce probably some sort of status or controller that summarizes information across all the claims made against a set of devices in resource slices, and then allow kubectl describe node and probably kubectl describe resource slice to be able to summarize that information And so I think that makes sense for this group to own it, but I want to know, are there, is there reviewer bandwidth and things like that over the next cycle?
I can help with that one. Makes sense to add that.
Makes sense to me for SIG Node to own that one. Yeah.
Okay, awesome. Then I'll let the assignee know because I think he signed it to SIG scheduling right now, but I don't think it's even touching scheduler, other than maybe adding some some checks in scheduler to use the information.
Do you want the status of devices also reflect the health the same way we do in pod status, or it's mostly for
I'm not even sure we're going to put it. I don't know yet. That's a separate cap that we currently are going to solve using a device taint with effect none. So we think that might be sufficient, in which case, so that's a separate discussion that I'd love your opinion on, Sergey. We've had that discussion back and forth, and the current status is just to we already have way too many things to do. So the current plan is we already have device taints. If we add a none effect status, we can kind of attach health information there. If we think there's use cases or a need for more and putting it in the resource slice status, which doesn't exist right now, then we can discuss it. There's actually a separate issue for that.
Yeah, because Kubelet will know about health to put it into pod status. So since we know the health information, maybe you need to put it all the way to the node status as well.
I see what you're saying. Yeah. I don't know. We can discuss it in the cap.
Awesome. Thank you. Yeah, that sounds good. I'm not seeing any other agenda items. Did anyone have anything else they wanted to talk about?
I have a quick question.
Yeah.
Unless no one has anything else. I don't know if this is the right group for in-place pod vertical auto scaling or if that's a different SIG.
Yeah, the in-place pod resize we own. The vertical auto scaling part of it is SIG auto scaling. So I guess the question is like which component of it, which like part?
Yeah, like I think like the actual pod component, I guess, not the actual like VPA or any aspect of that. I was just curious. I was trying to figure it out from the roadmap online, but we've had to, I was wondering if there's any support for custom resources or some hook to resize custom resources in that thing, or if it's something that, we're going to stick on CPU memory for now.
We don't have explicit plans to expand to custom resources right now, but it is something that we're thinking about and considering. So I'd definitely be interested in hearing more about your use cases.
Yeah, I can put together like a quick one-pager, but the main use case we have, I think I've talked to Don actually. This is on at Snap. Our main use cases, we have inference workloads, right? That they're portable between CPU and GPU. And one of the problems we have is we don't know ahead of time which capacity we're going to get. And so essentially what we would ideally want is that at binding time to the node, I could add or remove resources from a pod. But in absence of that, the auto scaling piece is good enough. But we can't do GPUs, right? Because it's only CPU memory right now. So what I'd want to do, like, our use case, right, is that a new inference pod comes in, we have queue and multi-queue set up, right? And we want to say, like, they don't have that particular resource queue, but they get scheduled on perhaps on-demand capacity, which they may or may not get, and then they get onto CPU. In that case, I want to load the CPU-based model, not the GPU-based model, right? And today, the resource requests after admission are completely immutable, right? So the scheduler already makes a decision. I can't additionally add a GPU claim. I can do weird stuff like using MIGs and stuff to like split the GPU, then try to reallocate it dynamically. But that's kind of our use case, and we have it all over the company where we have a lot of inference workloads that rely on like burstable or kind of unused capacity, and so that's kind of where I was wondering what is there a path forward to making it mutable at pod binding time to the node binding event, or is it just the sub resource resizer is kind of the right strategy to go with? And I don't know. That's kind of where we're at.
So if I can jump in here, so we actually have a solution to this with DRA because we have what we call prioritized list claims. So the idea is you can define your claims to say, hey, if you have GPUs available, give me a GPU. If you don't, then give me CPU. And we have a DRA driver, so Praveen is on here, that manages CPUs as well. So we're looking at exactly this use case, and I think we actually heard about it from our product management. I don't think we've had a chance to sync up. So I'd love to talk to you more about it and about a possible solution, and it would happen at binding time. So basically, we have a way also in DRA to put a hook in at pod binding time. And so what you could do is if you have two different images, for example, one for GPU and one for CPU inference, then based on which hardware is available, which is done when the selection is made in scheduling, the DRA prioritized list claim would allow either type of node to meet the requirement of the pod. And then at binding time, we can actually go in and swap the image on the pod, on the container, because the image is mutable. So that's kind of the high level overview of how we thought we could solve that. So I'd love to talk with you more and see if that works for you.
Yeah, that's a good, thanks for that information. As I was looking at the DRA drivers, it wasn't clear to me that you could remove claims or that the claim would like fall back to another type of claim, right? So that was something that was unclear to me. To give you context of how we do it today at Snap, like I build our own little admission controller, pod controller that basically listens on bind events. And then when it binds, we use the downward API to send different environment variables that way. So using annotations, I can like edit the annotation that flows into the pod that tells it to boot with CPU or GPU. That's how I got around immutability of environment variables. And then obviously we swap out to a different C++ like binary, one that's compiled for ARM or one compiled for Intel or compiled for whatever. That's kind of how, or like one that's compiled for, of course, GPU. They're like they compile one for every single architecture or sub-architecture. So that's kind of what we do now. The blocker we had, right, is just, it's more of a like observability problem. So we kind of worked around the problems of this by using a privileged container because you still have access to the devices. Of course, that breaks MIGs. It breaks like a lot of the observability in Google is the biggest problem actually, because you don't really know that the pod is claiming that resource, right? And so that's really the last like hook. That's what really broke a lot of things like auto scaling, other things like that, because the metrics were all messed up and because we're basically bypassing the whole NVIDIA driver, right? We're not binding the container DTOML and like binding the device correctly and giving the claim, and all these things rely on that, right? So that's where we kind of were hoping that VPA or the IPCC was going to allow us to edit that spec. And I think there was some initial PR like a year and a half ago or somebody allowed that at some point, and they decided to use the sub resource, which makes sense. So that's, if the DRA thing is a viable solution, that seems pretty useful to me as well. So, that's kind of, that sounds like it would pretty much do what we need to do. That combined with, as long as it plays nicely with multi-queue queues and like the gang scheduling stuff there, I think that would probably work okay for us. That's really just what we need, right? Like we have everything else working. It's really just like, can we make all the like observability things and not hack something that kind of works, right? But it messes up a whole bunch of other things that rely on, reading the pod spec and seeing there's a GPU claim and other things like that, right?
Right. It's kind of making an end run and things get confused. So, yeah, I think Praveen may even have a document we could probably share. So we can, and then we can, I'd love to understand, and it looks like Kevin's got a hand, maybe that's about queue. I'd love to understand the queue requirements.
Yeah, I was just gonna say I looked into it a little bit. I was more concerned about the potential of somebody using this feature to put low requests, get admitted to a queue, and then increase them so that they could get kind of away from the quota management. But queue by default will look at the difference of the workload, and if your workload doesn't match what was admitted, it will evict it. So
Interesting. So like it won't work.
At least that's my understand. At least when I played around with in-place resize, it was a good thing for queue for us. But yeah, like I have the issue where I discussed it and I was able to see that queue, like if you try to change those pod specs and the templates change, queue will evict. So
okay, so the templates are bad, but like
I'm sorry.
But the sub resource resize is okay, or that also counts as like a spec change in the context of queue.
Let me see which I reproduce it on. Sorry, I'm not an expert on this. I reproduced it on 1.33 using a sub resource resize.
Mm-hmm. Got it. That's good to know.
So on the Kevin, on the DRA side, there's some queue support for DRA. How does that what do we end up doing with the prioritized list claim functionality in DRA and queue? I know on the core Kubernetes quota side,
Yeah,
quote
I
by device.
understand your question. I have to check, to be honest. We did an alpha for this for a reason, and there are certain features that we may not have fully supported. Prioritized list was one that, as we were looking at it, was beta. I know that we had a part of the issue is if there's anything with cell expressions, I don't think we quite have the plumbing in place to kind of evaluate cell in the control plane and kind of get back like what it would actually pick, so we know what quota queue actually is going to get. So that was something that I know part of our goal for DRA and queue is to kind of get a lot of the GA functionality for DRA working, and we have some people kind of tackling that one now, and that's probably the main blocker from getting DRA and queue to beta.
So this seems like a good opportunity if we can understand Snap's requirements with queue and prioritized list solves the rest of the problem. We can make sure these things work together in a way that helps our customers. Okay.
Yeah, and that issue is there. Feel free. I don't know the person. P. Kyle. Feel free to post on there the issue for queue. Kind of bring this one up. I was thinking of it more as like a bypassing queue and not so much as the feature for supporting it when I was thinking of this.
That makes sense. Yeah, I think the biggest problem we have, right, is on-demand capacity, because sometimes you can get it, sometimes you can't, right? So we have reservations that we pull from using queue, and those are pretty easy for us to evict, right? And then maybe even fall back to a different workload in the queue, right, to the CPU workload. What we have a challenge with, though, is that is at times on-demand capacity and other things available, and or we can borrow from some other place. And that's where it gets really challenging, right, as an infrastructure to figure out, can it work? And you don't know until the pod's emitted, right? We don't know that it will work. And then that's where it gets challenging, because you can't modify the pod, or I can't do anything with it without deleting it and doing some crazy pod controller where I delete and try to catch the next creation. And that's just weird. There's not a good way to do that. So what we also do right now is we mirror the pods. So we have a vNode control plane, which is I don't know if that's SIG Node either. Maybe that's a different, I guess it's SIG Node, but we have a virtual node pool, or a virtual node that we use to mirror pods to get around this as well. So we'll take it on the home cluster and we'll actually schedule it in other clusters across the company. And that's how we get around some of these things, because at admission time, right, it's a new pod. So at admission time, I can do stuff and I can forward things. but it's not ideal because it makes things. We still have this problem with the CPU and on demand, right? There's nothing we can do because we don't know until it's too late. So I'm really interested to figure out like if the DRA thing is going to work. I can put together our user story or case and see and kind of, or since you've at Google, we could always do a meeting as well. So I'm happy to always collaborate on this in any way we can because we have a lot of work on this.
Yeah, awesome.
The Pio, thanks for bringing this topic to the SIG Node. Yeah, last time we discussed, I did bring your request to the team, internally, Google team. So for the DRA, I think at least John and I communicate it is possible pass. But I do have concern also for with the DRA because you clearly mentioned that on demand of the capability on that particular node. I'm not a lot sure about the performance, right? So that the performance, how we meet those kind of things, because there also have the complexity between of the different DRA drivers. So that's why Praveen, who is the CPU DRA driver owner, also have the several discussing on these cases with me. And there's the sum of those kind of things. Oh yeah, thanks for Praveen here. And yeah, there's the detail of those. Yeah. So can you just read just like what we discussed? Can you write this requirement into the one pager? So then we own this problem. At least the SIG Node own this problem, because you are not the first one to bring this request to us, but you are the only one have the concrete detail on the request. So we want to understand those kind of things in more detail and then give you the solution. Yeah.
Yeah, I'm happy to do that. I already have one, an internal one, so I'll just get it reviewed so that we can share it externally. But if it is inside Google, it's easy because we already have a relationship. So, but I'm also happy to share it publicly because I'm sure there's other collaborators.
If you want of the open Google for faster, because several owner also is Google owner here. Yeah.
Okay.
All right.
So we can discuss and propose together as the solution to the open source. Yeah.
Cool. Did anyone else have any more on that or any other topics? Yeah, I think we're good to adjourn. Thank you everyone for joining. See you next week.
Bye.
Thanks.